In this video, we are going to discuss about the Vmos, LED, LCD, optocoupler and solar cell. So first, what is mainly Vmos? It is this Vmos is actually used in the reduced power handling devices, and this has many positive characteristics which can change the construction mode from one planar region with a vertical structure. So this elements which are present in this planar MOSFETs are always present in the vertical metal oxide silicon FET, and the terminals are connection with the two terminals, that is SiO2 layer between gate and the p-type region that is formed between the drain and the source. Actually, the term vertical, why we are defining, is that the channel is now formed in the vertical region rather than the horizontal region, and this region is cut in the semiconductor base, which often stands out as a characteristic of mental memorization. You can see the applications of this positive voltage when it is coming from the drain, and the negative voltage to the source. It's a gate voltage of 0 volt. This will results in the induced N channel, and also the length of the channel is now defined as the vertical height of the P region, and which can be significantly less than that of the channel that uses the planar construction. So here the diffusion layers can be completely controlled by the small fractions of the micrometer, and when we are decreasing this channel length with the reduced resistance levels, there will be some changes in the power values. That is, this power values can be occurs mainly due to the loss in the form of heat which is operating beyond the threshold voltage. So when you are, in addition, you can say that this contact layer between the channel as well as the region which is greatly increased by the vertical mode can decrease the resistance, and also it can causes the increased layer of the current between the doping layers. If there is any existence between these two conduction paths between the drain and the source, then it can be results in some kind of drain currents also when it exits with the power levels of 10 volt. So comparatively, this commercially available planar MOSFETs or Vmos FETs will be having the reduced channel resistance when compared with the other planar MOSFETs, and it has the higher current and the power ratings. This Vmos FETs is having the high positive temperature coefficient. We can say that it is ultimately have the low compacting facilities of thermal runaway, and also the reduced charge will be highly faster switching times than compared with the Vmos. And LED, which is nothing but light emitting diode, and it is also same as that of the LCD, that is light emitting diode is a semiconductor light source which is used in the indicator lamps in many devices. Here, when the light emitting diode is forward biased, these electrons will be recombining with the electron holes with the device, which releases the energy in the form of photons. So this effect we call it as electroluminescence, and the color which is coming from the light will be determined by the energy gap of the semiconductor. Here the LEDs present many advantages over incandescent light sources, including the low energy consumption, longer life, improved robustness, smaller size, faster switching, and greater durability and reliability. The symbol of the LEDs are used in applications as the diverse as replacement, which can be used for the automatic lighting as well as the traffic lights. So it has the compact size with the narrow bandwidth, switching speed, and the extremely lightweight LEDs has been allowed very next to the video displays and sensors to be developed. You can see the IV characteristic. This is also same as like that of the xenon diode. When there is a change in the voltage, when it increases to a particular value, it goes to the reverse bias region. Solar cells. So as we have seen in the top view of the figure, you can see that every effort is made to ensure that the surface area which is perpendicular to the sun is maximum. So here, when we note the metallic conductor which is connecting to the p-type material, and the thickness of the n-type material are such that they ensure the maximum number of the photons of light energy that reach the region. A photon of light energy may collide with the valence electron and impart to a sufficient energy to leave the parent atom. This results in the generation of free electrons and holes. So this phenomenon will occur on each side of the junction. In the case of the p-type material, new generated electrons are the minority carriers, so that it can move freely across the junction, and also this will increases the change in the minority carriers, which can flow in the opposite direction of the conventional forward current. And under open circuits also, this voltage will occur, and the short circuit will be the linear function, which will be the double same increase in the illumination. When there is a major increase in the VOC, there occurs the lower level of increases in the illumination. And the characteristics of voltage current curve for the solar cell is given here. So whenever there is a change in the voltage, there will be change in the input and the output voltage. Thank you.